Okay, here's page 2 of the review for our Unit 8 test about volume. Now these say there are non-calculator, so there's probably going to be some fairly easy polynomials or easy things to anti-differentiate, hopefully, fingers crossed, and we get answers that are not crazy decimals. So find the area of R in the first quadrant enclosed by the graph of y equals 2x and y equals x squared. Okay, so the first thing we're going to do is sketch because we need to know where these things intersect. Okay, so 2x I'm going to do in blue. That crosses at your origin and is up 2 over 1, up 2 over 1, up 2 over 1, right? So this is the graph of 2x, has a 0y intercept and a positive 2 slope. Okay, I'm only concerned about the first quadrant. Okay, so then y equals x squared is your next one. That's 1 right, 1 up, and then 2 right, 4 up. So this is the graph of x squared. And this is the graph of 2x. Okay, so we're trying to find this tiny region in between here, the area between these two curves. Okay, so area is the interval from, looks like 0 to 2, right? That's where they both cross. They cross at 0 and they cross at 2. Okay, of your top function, which is 2x, minus your bottom function, which is x squared dx, right? There's nothing crazy here. It's just the top function minus the bottom function. Okay, it's when we start doing volume that we have to square that difference. But this is just area. Okay, so let's take the antiderivative of 2x, which is just x squared, right? So it's 2x squared divided by 2, but 2 divided by 2 cancels out, right? So 2x squared divided by 2. So x squared minus x cubed over 3, and we're going to evaluate that from 0 to 2. Okay, so nothing too crazy here. So 2 squared is 4 minus 8 thirds minus 0, of course, because that's what you get when you plug 0 in. What do we got to change 4 to something with thirds? So 4 as a third is 12 thirds, because 12 divided by 3 is 4. So then 12 thirds minus 8 thirds equals 4 thirds. 4 thirds square units, right? Because it's an area. Area is always a squared unit. Okay, write but do not evaluate an integral expression for the volume of the solid when r is rotated around the horizontal line y equals -3. Okay, so we're going to use the same graph here for a second, and -3 is down here. Right, so we have the volume equals pi times the interval from 0 to 2 of the farther radius, right? So the radius here is your 2x minus -3, right? That's the radius of the farther function, which of course becomes a plus, but you can leave it as minus a minus, right? This is not a solving one. It just wants to see if you know how to set it up. Minus the second radius, or the closer radius, which is your x squared function, also minus -3 squared, okay, dx. And that's all they want you to do here, is they want you to set it up. Okay, because solving it would mean squaring this thing and getting fourths, and it would be kind of messy. So they're not really worried whether you can solve it. They just want you to set it up for this problem. Thank you very much. Okay, number 10. We're going to change something about -10 and change it to y equals 6 as your rotated line in a second. So here we have find the area R of the figure to the right. Okay, so it looks like we have an area from 0 to, I guess what, 4, and then from 4 to 6. You want to separate it into 2 integrals, or you want to do it as 1 integral? Okay, so if we find the integral from 0 to 4 of root x dx, and we add that to the integral from 4 to 6 of 6 minus x dx. Okay, maybe this would be an easier way to do it rather than just taking, I guess it would probably be the same thing, wouldn't it? I don't know, there's this thing here, right? That might give us something different if we, yeah, it'll be fine. We're good. It's good. We'll do this. Root x from 0 to 4 and 6 minus x from 4 to 6. So let's look at our root x function. Okay, so what is the antiderivative of x to the 1/2? Okay, so we usually change your radical into, or rather your root into a power before we use the polynomial rule, right? So we add 1 to the power when we take the antiderivative, and we divide it by that new power. So multiplying by the reciprocal is 2/3 of x to the 3/2 power. Okay, and we're going to evaluate that from 4 to 0. So basically it's 2/3 times 4 to the 3/2 power. Okay, so there's lots of ways we can think about this. We can do 4 cubed, which is 64, and then take its square root, which is 8. Or we could do the square root of 4, which is 2, 2 cubed, which is 8. Okay, so either way, this whole entire thing becomes 8, right? 4 to the 3/2 power equals 8. 8 times 2 is 16/3. So this much of your integral becomes 16/3. And now 6 minus x, that one's pretty good. That's just 6x minus x squared over 2, evaluated from 6 to 4. Okay, so this is a non-calculator, so we're doing this by hand. 6 times 6 is 36 minus 18, right, when you square 36 and divide it by 2, minus 6 times 4 is 24, minus 4 squared is 16. 16 divided by 2 is 8. Okay, so this is 18 minus 16, which is 2. So this area here is 2, and this area over here is 16/3, right? 16/3. 16/3 plus 2, I guess is 6/3, is 22/3. 22/3. Okay, so if we can break this into two shapes that are a little bit easier to anti-derive and then add them together, that might just be the ticket that we need. Okay, so we're going to set this one up and then use our calculator because why not? So x equals 6 is this line right here. Okay, x equals 6, x equals 6. Okay, so what we're doing is a horizontal rotation, right? We are rotating it this way around your circle. This is becoming your circle. So a horizontal rotation needs y value everything. Y value everything's. Okay, horizontal rotation. So volume equals pi times the integral from your y values. Looks like we have an integral from 0 to 2, right? This is the y value. So from 0 to 2, that's your integral. And y value, 0 to 2, of your farther radius. Okay, the farther radius is your square root function. Oh, but solved for y. So we got to solve this equation for y. That's pretty easy. X equals y squared. Done. So y squared minus 6 squared. All right, because that is it's your function minus your axis of rotation minus your other function minus the axis of rotation. So this one is 6 x minus 6. Let's solve this for x also. So x equals 6 minus y. So 6 minus y minus 6 squared dy. Okay, so when you're doing a horizontal rotation, everything needs to be in terms of y. Your intervals need to be in terms of y, so they're y value intervals. And your equations need to be in terms of y, and everything else needs to be in terms of y. Okay, so don't forget that when you're doing it. Now, we, of course, use a calculator to do this because I think it's pretty arduous to do by hand. So to save time, we're not going to do it at all. If you want to plug it into your calculator, that's fantastic. Okay, number 11. Here we have 10 minus y squared. So if you remember from your pre-calc classes, positive y squareds open to the right at the origin. Negative y squareds open to the left at the origin. Okay, so there we are moving this y squared 10 units to the right. Okay, so yes, this requires you to know a lot about pre-cal 4, 5, 6, 7, 8, 9, 10. Okay, so 1 up, 1 left, 1 down, 1 left, 2 up, 4 left, 1, 2, 3, 4. Right, so it's your classic parabola just graphed sideways. Okay, so this is the graph of 10 minus y squared. Okay, and then we have x equals y minus 2 squared. So usually if you have parentheses, parentheses lie, and a minus 2 would move it to the right. Okay, if it were an x minus 2, it'd move it to the right. But because it's a y minus 2, this moves it up. So we are moving our graph of y squared up 2 units. So we go up 1 over 1, good, it intersects there, that's nice. Down 2 over 4, down 3 over 9. Oh, beautiful, these things intersect at nice y values. Okay, so they intersect at -1, and they intersect at +3. So when we're doing this interval, right, it's a y-axis interval, because I'm sure it's finding the area of y. That's okay. Let's do that. Okay, so the area is just the interval from, I guess, -1 to 3, because those are the y values where these things intersect, right? The y values here and the y value there. When you're doing a y-axis, it's from the right. So it's the right function minus the left function. So your right function was 10 minus y squared minus your left function, which is y minus 2 quantity squared dy. Okay? So when it is an x-axis thing, you go top to bottom. When it's a y graphs, you go from right to left, right? The positive direction towards the negative direction. Okay, so -1 to 3 is your interval. The right function is 10 minus y squared. Well, I don't know why I'm squaring this. I should not be squaring this. I need to erase this second square. There we go. And that means I can erase these parentheses too. Let's just erase it all and write it again. Minus y minus 2 quantity squared. Okay, so to do this by hand, we would multiply it all out. I think your y squareds might cancel out. Ooh, maybe they won't. And you'd be able to take the antiderivative of a nice polynomial function. Okay, so know how to do that. Write but do not evaluate when we rotate around the line x equals 0. So once again, that is a vertical line. So we're going to have a horizontal rotation. Okay, when we have a vertical axis, we have a horizontal rotation. So everything needs to be in terms of y. And, well, everything already is in terms of y. So that's not bad at all. Pi times the interval of -1 to 3. Once again, they're y values. Of your farther radius. So the farther radius is your 10 minus y squared graph. Okay, and we're squaring that because now it's a pi r squared equation. Minus the closer one, which is the y minus 2 squared quantity squared graph dy. Okay, and of course you don't have to put the -0 in there because -0 and +0 is always implied in an equation. Okay, but it wouldn't be wrong if you did. If you put a -0 in each of those equations, it would be correct. Okay, so there's page 2. Take the time if you need to take those antiderivatives. Okay, practice doing it by hand. You have more questions to do by hand without a calculator than you have with a calculator. Okay, hopefully that helps.